Hey guys, welcome back. So we are looking at 8.5 today, so we'll go ahead and get started on that. So for the first section, we are taking and looking at verifying that the given point lies on the graph of the parabola. So for number one, it says the point 6, 0, and we have the equation of the parabola y equals 2x squared minus 9x minus 18. So how we're going to take and go about deciding if it lies on the parabola is by plugging in the point into the equation. So 6 represents our x value, 0 represents our y. So we're going to have 0 equals 2 times 6 squared minus 9 times 6 minus 18. So 6 squared is 36. And 36 times 2 is 72, minus 9 times 6 is 54, minus 18. So now we're going to subtract all of these. So 72 minus 54 minus 18 is going to give us 0. So because it ended up working out, this is a true statement. The answer is yes. 6, 0 lies on the parabola. So that's what you're going to do for that first section. You're going to take the given point and you're going to plug it in for the x and y. Now make sure you plug the x in multiple times. It's going to happen since there's the x squared and the x value within there, and then see if it ends up equaling what the y value is. Okay? All right, so that is for questions 1 through 5, essentially. 6 is based off of the picture that's there and ways that you can take and test it and work through that. So the next thing we're going to look at, I'm going to switch over to the workbook for a second just so you can see it. So what we're looking at here, this is the picture that we're going to be using to answer number 7 on the whiteboard since there's a lot to write out. It says, use the diagram in figure 2 right here, to derive the general equation of a parabola, based on the geometric definition of a parabola. Remember that the definition states that MF equals MQ. So what we're going to take and do first is set in what we know based on what we have. So we're going to find the length of MF, which is this right here, which means we're going to use the distance formula. So we're going to have our x2 minus x1 squared plus y2 minus y1 squared. And then MQ, the distance between that, is just the distance between y and our negative p. So y minus negative p for that. So I've got this started, and then we're going to take and work together to solve it out. So let me just go back to my whiteboard real quick. Give me one sec. Sorry. Okay, there we go. So this is what we have here. So this is showing the distance for MF is this equation with the values that we have from that picture plugged in. Same thing with MQ. And because MF and MQ are supposed to equal each other, we set each of these things equal to one another. So that's why I have y plus p equals the square root of 0 minus x squared plus p minus y squared. So now we want to get rid of the square root. So I'm going to square both sides. That'll get rid of the square root. So now I have y plus p squared equals, and then obviously 0 minus x is just a negative x. Negative x squared is x squared plus p minus y squared. So this is what we have now. Now we need to take and actually do FOIL on our two binomials that are being multiplied. So we're going to have y squared plus 2yp plus p squared. Now, the reason I was able to do that so easily is because this is a perfect square trinomial, which means we square the first number, we square the last number, so that's how I got the y squared and the p squared. Then we multiply the two values together and then multiply by 2. So that's how we get the 2yp. and then equals x squared plus, same thing over here, but we're going to have a negative in there. So we've got p squared minus 2py plus y squared. So this is the next part of that. So now we want to take and combine any like terms and simplify this down as best we can. So we've got a y squared on both sides, so that can cancel out. We've got we've got a p squared and a p squared. Those will both cancel out. So those are gone. So now we have 2yp equals x squared minus 2py. Now, the fact that over here I have yp and over here I have py doesn't matter because it's being multiplied, so we can combine these. So I'm going to add the 2py over plus 2py over. Cancels out over here, so now I have x squared equals 2 plus 2 is 4, so 4py. Oops, sorry, reflection. So we have the x squared equals 4py, and now we want to get x by, or let's see, not x by itself, we want to get y by itself, so we're going to divide by 4p, divide by 4p, so we end up with 1/4, let's see, 1/4 px squared. Now this p is attached to the 4, so that p is in the denominator of this fraction. It's not being multiplied to the x squared. First you have to multiply it by the 4. And then this equals y. So there is our equation. So a value is 1/4p. So that's what we're looking at there to show what the a value is. So now, question 8, recall the equation in number 5. Y minus 1 equals 1/4 x squared. What is the value of p? Well, what's the value of p going to be if we have the 1/4 x squared? Y equals 1/4 x squared. Y equals 1/4 p x squared. So p has to be 1. P equals 1. So for number 9, I already have this answered, but in general, what is the value for p for any parabola? Sorry, I can't talk. Parabola. P is the distance from the vertex to the focus, and P is the distance from the vertex to the directrix. So directrix is your keyword for this lesson. Directrix. Remember, the directrix is that line that is to one side of the parabola. So it's that horizontal, or it can be a vertical line, depending on our parabola, and it's P away from the vertex. And P is also the distance from the vertex to the focus. So 2P is the distance between the directrix and the focus. Okay, the next thing we're going to take and look at is back to the workbook here. So you'll have question 10 to do on your own. You're going to be taking and finding the coordinates, so figuring out what those are. So next thing we're looking at here is, once again, we're going to take and graph out our parabolas. So if we look at this, it says sketch the graph by finding the vertex and the point M and R, the reflection of M, as defined in the diagram above. Use the geometric definition of a parabola to find the equation of these parabolas. So we know what the directrix is. It's y equals 9. We also have the focus. It's -3, 7. So zoom this in to make things a little easier for seeing purposes. Okay, so our directrix is y equals 9. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's this up here. Let's see if I can actually draw a nice straight line today. No, but we'll pretend that's a nice straight line. It's okay. You guys can draw a nicer line than I can. Okay, the focus now is at -3, 7. So we're going to go over -3 and then up 7. So 1, 2, 3, 4, 5, 6, 7. So there is our focus. There is our directrix. So we have that taken care of. Now, from the focus to the directrix is 2. Remember, the vertex is going to be halfway in between. So let me change the color on this. So the vertex will be right there, which is the point -3, 8. Remember, when we have our focus, the focus and the vertex are always going to have the same x value when it's a parabola that's either going facing up or facing down. We will eventually get into parabolas that'll face left and right, or I should say open left and right. But for right now, we're just dealing with the up and down ones. Okay, so now for the equation, we're going to have y equals, now remember, we have to have that 1/4 p x squared. So 1/4 p, what's the p value in this case? How far is our vertex from our focus? 1. How far is our vertex from our directrix? 1. So that means our p value, so p equals 1. So that means we're just going to have the 1/4 x plus 3 squared plus 8. So the 3 and the 8 come from our vertex. So now to take and get our point, we're going to take and we can plug in a value. So I'm going to plug in 0. 0 plus 3 is 3. 3 squared is 9. 9 times 1/4 is 2 and 1/4 plus 8 is going to give me, hang on. Oh, sorry, it's a -1/4. Hang on. So make note of that. I missed the negative on that. So remember, it hugs the directrix. So this is actually a -1 distance-wise. I apologize for that. So 3 squared is 9 times the 1/4. -1/4 is -2 and 1/4. And then we're going to add 8 to that. So we get 5 and 3/4. So we're going to go up 1, 2, 3, 4, 5, and 3/4. Maybe if I can get the dot on there. Okay, and then we go over 3, and then over 3 more. So 1, 2, 3, right there. And now we have our parabola. Obviously, yours will be a little more of a curve, unlike mine that's a little too straight since I'm on the computer and it makes it a little difficult. But there is our parabola. All right, we're going to do one more together just so you guys have multiple examples for your 13 and 14. So number 12, our directrix is y equals -6. So we're going to go down to -6 on the y-axis. So 1, 2, 3, 4, 5, 6. So there's our -6. Let's see if I can draw a straight line this time. Hey, not too shabby. Okay, and then our focus is 2, -2. So we're going to go over 2 and then down 2. Okay, so now remember our vertex is going to be halfway between that point and our directrix. So from here to the directrix is 1, 2, 3, 4. So half of that is 2. So there's our vertex. So P equals 2. Keep that in mind. So then our vertex is the point 2, negative, well, if this is -2, 3, 4, so -4. All right, for our equation, we're going to have y equals 1/4. Now, because it's going this way, because remember, it has to hug, as it like to say, hug the focus. It's going to be facing upwards. That means that's going to be positive. Whoops. But is it going to be 1/4? No, we take 1/4 and we multiply the 4 by our p-value. So 4 times 2 is 8. So this is going to be 1/8. And then x minus 2 squared minus 4, since that came from our vertex there. So there is our equation. Now we need to take and graph this out. So I'm going to use the point 5. So 5 minus 2 is 3. 3 squared is 9. 9 times 1/8 is 1 1/8 minus 4 gives me a negative 2 and 7/8. So we're going to be at 5, so 2, 3, 4, 5, and a negative 1, 2, and 7/8. So there's our point. Then we're going to go over 1, 2, 3, and over 1, 2, 3, and there's our point. So remember, they're always symmetric. Let's see if I can get a nice curve on this one. Kind of, sort of. So there is your parabola. All right, you guys will do the same thing for 13 and 14. All right, the last section, we are finding the minimum and minimum values for quadratics. So find the maximum or minimum value of the quadratic, indicate which it is. So in order to take and do these, what we need to take and do is figure out what the vertex is. So we need to put this into vertex form instead of standard form, which means we need to take and complete the square. So I'm going to go ahead and show this on I can show it here, I think. Okay, so we group these two together. The negative 5 stays on the outside. We take the 6 and divide it by 2. We get 3. 3 squared is 9. So now we have the equation y equals x squared plus 6x plus 9 minus 5 minus 9. So because we added 9 here, we're going to subtract 9 over here because we have to do opposites since they're on the same side of the equal sign. So this is a little different than what we were doing just last time. So now we factor. So y equals x plus 3 squared. Remember, whatever this value is, it goes right here. And then negative 5 minus 9 is going to give us a negative 14. So our vertex is negative 3, negative 14. And so that means we have a minimum when x equals negative 3, min is negative 14. So it's all about what your vertex is. So you're just taking and solving for that vertex. All right, next one we're going to look at is 18. So same thing, we're going to group the first two together. Now, these two have a value in common. They're both divisible by 3, so we're going to have y equals 3 times x squared minus 4x, leave a space, plus 8. Now we take our negative 4, so negative 4, we divide it by 2, we get negative 2, and then we square that to get 4. So we're going to add a 4 in here, and we're going to subtract a 3 times 4 here. So then we write our factoring, so y equals 3 times x minus, sorry to write the wrong thing, x minus 2 squared plus, well, won't be plus anymore. So negative 3 times 4, this all becomes the negative 12. So 8 minus 12 will give us a negative 4. So we have, let me erase that. Hang on. Minus 4. So our vertex is the point 2, negative 4. So because this value is positive, so when your x squared is positive, that means you're going to have a minimum. So we have a minimum when x equals 2, minimum is negative 4. So these two are very similar in how they are, but this one had that value out front, so we have to take that out. But then when we subtract what we added inside the parentheses, if there's something outside the parentheses, we have to multiply that to what's being subtracted on the inside as well. So for 17 and 18, make note you have negatives on your x squared values. Same thing with 20, which means you're going to have maximums. But you'll work it out just the same. Same 19, it's positive, so that means you'll have a minimum for it. All right, have a wonderful week. and happy mathing. A reminder, your keyword is directrix. Keyword is directrix. All right, have a wonderful week.